Today we're going to be doing more of the same from yesterday, which is adding and subtracting fractions, but we're going to add more factoring to it. So if there's factoring to be done, we'll need to do that first in order to add or subtract fractions. This first one actually doesn't involve any factoring. I'm going to rewrite the question, leave some space in the front, and leave some space behind. And again, can we cancel out these p's? No. This adding and subtracting groups things together. And so all of these are grouped as single factors. And in order to add or subtract fractions, we need our denominators to be the same. So in this first fraction, it doesn't have a p plus 1. So I'm going to write, good in green, p plus 1 down here, but then I would also have to multiply by p plus 1 on the top. The second one doesn't have a p minus 2. Excuse me. So I'd write that factor on the top and the bottom there. Because now I can double check, and sure enough, I've got p plus 1, p minus 2, and p plus 1, p minus 2. And I would leave my denominator in that factored form, because later we might be able to simplify something, and if we want to simplify, things need to be factored. But in my numerator, I need to add the things on the top, so I'm going to need to expand them out to look for like terms. So I'm going to put a set of brackets here and a set of brackets here. When I multiply p plus 1, p minus 1, that's a difference of squares. So you're going to get p squared minus 1. And I hope at this time you're able to go right from here to writing it in simplified form. So I would say p times p, p squared. Can you do the outside minus 2p and the inside plus 3p at the same time and combine those like terms? So just to save us some time in writing, because if you didn't, you'd have to take a whole other step to combine them. And you have to rewrite everything. When we're showing our work, we have to make sure that what we write is always equal to what was right above it. So the last one, 3 times 2 minus 6. Now I have a common denominator, which says I'm allowed to add my numerators together, keep my denominator the same, so I'm going to write my denominator p plus 1, p minus 2. And on the top, do I have like terms? Yes, p squared plus p squared would be 2p squared. I just have the single p, no like terms with that, but the minus 1 and the minus 6 would be minus 7. Now, we might be able to factor the top and simplify it. So you need to check the top if you can factor it. And in this case, how quickly can you tell that the top can't be factored? Excuse me again. I mean, if I was checking to see if it could be factored, I think in my brackets here, it would have to be 2p and p, and either 7 and 1 or 1 and 7. You see that those are your only possibilities if you could do it. And if I check option 1, outside and inside, 2p and 7p doesn't work ever to get a single p. If I check the second one, 14p and 1p, that would never make 1p, adding or subtracting. So a quick check, and it tells me that nothing works, can't be factored, this would be done. And again, the textbook writes down all the non-permissible values. So both -1 and 2 would cause us to divide by 0. So we've written it as a single fraction. Nothing cancels out, so it's in lowest terms. This is our final answer. All right, for B. In B, we have something that can be factored. And this will be very important for figuring out a common denominator. So to start off with, I have 2 over e minus 3. And then I have a subtraction sign. And then I have 3e over 9 minus e squared. And you have to be able to quickly recognize 9 minus e squared is a difference of squares. I can factor a difference of squares to be 3 plus e, 3 minus e. This would get grouped together. And here's the first place where we could run into some big trouble if we don't see something. The trouble that we could run into is if we don't see the special note that we had from before, that when factors are almost the same with a minus sign, but in the wrong order, you can factor out a -1. And if you factor out that -1, the e would have been negative and the 3 would have been positive. But now it matches up with the e minus 3 over here. So I'm going to rewrite things. That -1 factored out. Because now you see, I'm just going to underline it in purple, that at least those two are the same. So if I want to add or subtract to get a common denominator, right? I want to add or subtract, I need to get a common denominator first. At least something's the same now, which makes the common denominator smaller, which can be really disastrous if you make it too big. We'll see that in an example coming up in the next question. So, now we also have some options. And I hate it when math has options, because for students you like it when things only have one option, right? Because then that's the only thing you have. I only have to remember one way to do something because I have one option. Okay? I'm going to show you a couple of options in this. First of all, what I think is probably the easiest to see, and then I'll do what I would like to do the most. Okay. So the easiest to see would be this. Well, in order to add fractions, I need a common denominator. Do you see that this first one is missing a 3 plus e and a 3 plus e? What else is it missing? It's missing the -1. So I can put a -1 here and a -1 there. That would get me a common denominator. And going from here, everything else would work. Now, me personally, I probably wouldn't, there's options with the -1. So I would probably choose a different option with the -1. So I'm going to show you how you have options with the -1. If you have a fraction and there's a negative, right? 2 over -3, that negative's on the bottom. That's exactly the same as having the negative on the top. Agreed? Which is exactly the same as just saying the negative's out in front. So for me personally, what I would do in this situation is I would take this negative and I would move it out in front. Then it's not there anymore. What happens when you move that negative out in front with that minus sign? It'll change to a plus sign. So I wouldn't worry about the negative there. I would do that instead. I like it better because I don't have extra negatives anymore. Adding is easier than subtracting, so I like that better as well. So, but it wouldn't have been wrong if you just had that negative in your denominator as well. So now, that being said, this will have to get distributed. I have a common denominator of 3 plus e and e minus 3. Is everybody okay if I change the 3 plus e to e plus 3? Generally, we write our variables in that order. We write variables first and then constants at the end. something inside me was like really struggling because I didn't like writing the 3 plus e that way. It's not wrong. You could leave it as 3 plus e. But this makes me happier. Up here, if I distribute, I'm going to get 6 plus 2e. And over here, I'm going to have plus 3e. Do I have like terms on the top? Absolutely. 5e plus 6 over e plus 3, e minus 3, non-permissible values. E can't equal minus 3 and e can't equal plus 3. I check the top. This would all be grouped together. It does not cancel with any identical factor on the bottom. It also has nothing that you could factor out of it. So then this would be our final answer with things simple. Questions you can circle are 3, 4b, 5, and 8.